Okay, let's continue with 31, and I think that's on 499 as well. The integral from tangent to the fifth dx, tangent to the fifth x dx. Well, although tangent has power 5 here, going back to our notes, so I would be thinking of replacing tangent squared by secant squared x minus 1 if that's needed, if it helps. So let's see, first of all, what we can do here. Well, I'm looking at tangent to the fifth, and I know I can split it as tangent x, and tangent squared, everything squared. 4 plus 1 is 5. Now, as we just discussed, I'm going to replace tangent squared by secant squared, x minus 1, everything squared dx. I will expand this and then distribute. The integral from tangent x, secant to the fourth minus 2, secant squared x plus 1 dx. And then I'll distribute and create three integrals. This with this, this with this, and this with that. So the integral from tangent x secant to the fourth dx minus 2, the integral from tangent x secant squared x dx, and plus the integral from tangent x dx. So this is already very clear. We know we have the answer. We worked on this previously. But let's work on these two. So now we see in these integrals, secant has even power. So we are going to use the notation u equals secant x, where du equals secant tangent dx. Differentiate secant, that's my page 6, and you get secant tangent. Okay, so I'm looking at the first integral. I have to borrow a secant tangent, tangent secant, or secant tangent dx, but I still have 3 left over. Okay, fine. So u to the third du minus 2. Here I have the same idea. Secant tangent is going to be du, but I still have a secant left. So this is the integral from u du. And the answer for this we already have from a long time ago, natural log of the absolute value of secant x. And now all I need to do is write u to the fourth over 4 minus 2u squared over 2 plus natural log of the absolute value of secant x plus a constant c. Of course, I'll simplify, and now I have to replace u by secant x. Secant to the fourth over 4 minus secant squared x plus natural log of secant x plus a constant c. Okay, I also would like to remind you of the formulas also from pre-calculus. Product to sum formulas. There are 3. Here they are. Sine A times cosine B is 1/2 sine A minus B plus sine A plus B. Second formula, sine A times sine B equals 1/2 cosine A minus B minus cosine A plus B. And the last one is cosine, of course. Cosine A, cosine B equals 1/2 cosine A minus B plus cosine A plus B. And let's look at an example, see how this works. And look at 59, and I think it's on the same page, 499. We're given the integral from sine 3x times sine 6x dx. we look up the formula for sine, so it's this one. So we are replacing the function by 1/2 in front, of course. Cosine a minus b, cosine 3x minus 6x is negative 3x. And then minus cosine of a plus b, 3x plus 6x, 9x dx. Let me refresh your mind, your memory, on odd and even functions, trig functions. So that's 7. So odd trig functions and even trig functions. The odd are all ones that have sine in them. Sine x, tangent x, cotangent x, cosecant x. They're all odd. They have sine in them. The even trig functions are only the ones that only have cosine in them. So cosine and secant. Why am I discussing this? Is because cosine negative 3x, because it's an even function, cosine negative 3x is cosine 3x. So I'm going to jump over the explanation and move on here. So we have a 1/2, the integral from cosine 3x minus cosine 9x dx. So then the final here is 1/2. And we have sine 3x divided by 3, of course, minus again 1/2. Sine 9x divided by 9 plus a constant c. And yes, we will rewrite sine 3x over 6 minus sine 9x over 18 plus a constant c. Okay, so now I would like to look at one more example, which is an application with volumes. So let's look at 71, and again, I think it's on the same page, 499. Okay, so we are given, find the volume obtained by rotating the region bounded by the curves about the given axis. Okay, fine. So y equals sine x, y equals cosine x. We are given x between 0 and pi over 4. And they're asking us to rotate about y equals 1. About y equals 1. Okay, so like before, we always have to picture and see graph and see where the area is, etc., etc. Okay, so this is 0, this is pi over 4. X equals pi over 4, this is x equals 0. Let's say this is 1. Of course, y equals 1. And when we graph sine, we know that at pi over 4, both sine and cosine have the same value. So we know that sine pi over 4 equals cosine pi over 4 equals the square root of 2 over 2, which is approximately 0.71. So if this is 1, 0.71 will be roughly here. Sine starts at 0 and goes to 0.71. I'm going to use a different color. For cosine, that starts at 1 when x is 0, starts at 1. And of course, it's not a straight line. I don't want you to think that this is a straight line. So, and they meet here. So this is the cosine x function, and this one is the sine x function. Okay. So obviously the enclosed area is right here. They're asking us to rotate it with respect to y equals 1. So then the graph will be something like this. And so on and so forth. I don't want to put too much on it. So because we are rotating, we have to decide what to do, but I think the easiest thing is, since we are rotating with respect to a horizontal axis, and I realize that for a particular x value, this is the disk, a piece of the disk, of course. So we are going to be using disks or washers in this case because there is an empty center right here. So then, let me move on to page 8. So therefore, the volume will be pi, the integral from 0 to pi over 4, from the radius squared, the outer radius minus the inner radius, and of course dx. So the outer radius, this is the outer radius, which is 1 minus the y value for this x, but the y values is sine. So again, the radius up here at the bottom, the outer radius, rotating with respect to y equals 1, is 1 minus sine x. 1 minus sine x, everything squared, minus the inner radius. It's this tiny piece here. That's the lowercase r. So it's still 1 minus the y for this function. So 1 minus cosine x, everything squared, and dx. The outer radius squared minus the inner radius squared. So let's see what we get next. Of course, we have to simplify as much as possible. 0 pi over 4. So I have 1 minus 2 sine x plus sine squared x. Careful here. Minus 1. This will have a minus with minus in front, plus 2 cosine x. And it will be plus cosine squared, but with minus in front is negative cosine squared x dx. Luckily, these two go away. Fine. Pi, the integral from 0 to pi over 4. Negative 2 sine x plus 2 cosine x. Obviously, these are exactly what we just discussed. We have to reduce the power. So this will be plus 1 minus cosine 2x over 2, and this one is minus 1 plus cosine 2x over 2 dx. So I'm going to just calculate these. So negative 2 pi, a positive because I need cosine. So cosine x, 2 cosine x prime is negative 2 sine. So from 0 to pi over 4 plus 2 pi sine x from 0 to pi over 4. So I'm done with these two. And now here, plus, I will factor out 1/2. So pi over 2, the integral from 0 to pi over 4. So 1 minus cosine x minus 1 plus cosine x is negative 2 cosine 2x dx. So 1 minus cosine minus 1, the 1's go away. Minus 2 minus cosine 2x minus cosine 2x is minus 2 cosine 2x. Okay, so let's try to evaluate these. So when I plug in pi over 4, I get the square root of 2 over 2, minus when I plug in 0, I get 1, plus 2 pi. When I plug in pi over 2, I get the square root of 2 over 2, and when I plug in 0, I get 0. Minus, the 2's go away, pi, and we have here sine 2x over 2 from 0 to pi over 4. Okay, so what do I have? So I have pi the square root of 2. Then I have minus 2 pi. Then I have plus pi the square root of 2. And then minus pi over 2. And when I plug in pi over 4, 2 times pi over 4 is pi over 2, so this will be 1. But when I plug in 0, I get 0. So what is going on here? I'm going to factor out pi. So the square root of 2 plus the square root of 2, I have 2 the square root of 2. Minus 2 minus 1/2 is minus 5/2. So 2 the square root of 2 minus 5/2 pi. This is it. Thank you.